Okay, so today we're looking at cumulative frequency. So this is a frequency table. A frequency table just tells you how often something happens. So this one's about shoe size. So in this sample of actually 20 people, it happened 3 times that people had a shoe size 4. It happened 8 times that people had a shoe size 6, and so on. So that's a frequency table. Frequency has a slightly different meaning from frequency in physics, where it's how often something happens per unit time. Here it's just how often it happens. So there's your frequency, and here's your cumulative frequency. And it's really easy to do. It's just a running total. So up to that point in the table we have 3 people. Up to that point in the table we've got to add on another 4, so we've got 7. Then we've got to add on another 8, so we've got 15, 18, and then you can see that finally there are 20 people in total in this table. So that's a cumulative frequency column. That's all there is to it. It can be useful. So it depends on how you like to do things, like working out the quartiles. So it can be useful because a question in an exam can be add a cumulative frequency column to this table. It's like that. It's easy. You can do it. I would use it to help me find the quartiles, because you can do the quartiles by writing out a list. So you know there are 3 people with shoe size 4. You know that there are 4 people with shoe size 5. And so on. I get very, very bored doing that. I know that there are 20 people in total. 20. I know, therefore, that in the lower half there are going to be 10 people, and in the upper half there are going to be 10 people. So Q2 is going to be halfway between the 10th person and the 11th person. So let's see where those people are. Up to here we've got up to 7 people, and then up to here we've got up to 15 people. So the 10th and 11th people must both be in that row, so Q2 has to be whatever that row is, which is shoe size 6. Looking at the quartiles, so if I'm going to take a group of 10 people and I'm dividing them in half, I'm going to have 5 people in each half. So here I've got Q1 being halfway between the 5th person and the next person up, the 6th person. So where are the 5th and 6th people? Well, up to 3 people are here, and then up to 7 people are here. So the 5th and the 6th person must be in this row, and in this row everybody has shoe size 5. So the shoe size must be 5. Okay, let's look at Q3. 5. So 5, 10, 15. So Q3, it must be halfway between the 15th person and the 16th person. So where are those people? So the 15th person is in this row. So it's going to be halfway between 6 and the 16th person is in this row, halfway between 6 and 7. Now, halfway between 6 and 7 is fairly obviously 6.5, but you can do it as a sum if you want. But it means I can work out the median and the quartiles without writing the list. Now, if you prefer writing the list, that's fine. It's just a bit boring. So where had I got to? I had 4 people with shoe size 5. I'm going to have 8 people with shoe size 6. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to have 3 people with shoe size 7. 1, 2, 3. And I'm going to have 2 people with shoe size 8. I can split that in half because there's 20 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can see that Q2 is going to be halfway between 6 and 6, which is 6. 1, 2, 3, 4, 5. You can see that Q1 is going to be halfway between 5 and 5, which is 5. 1, 2, 3, 4, 5. And you can see that Q3 is going to be halfway between 6 and 7, which is 6.5. So either way is fine. It's just that the more numbers there are in the table, the longer it takes to write the list, and the more chance there is of me making a mistake, which is why I prefer not to do it. Right. You can also get frequency tables which are grouped frequency tables. You will have seen these in second year. And where it's something like shoe size, you're either a size 4 or you're a size 5. Okay, you could have been a 4.5, depending on whether your particular style shoe does 4.5, so I ignored them. But there's going to be sort of discrete values. For height, you can be 150, you can be 151.2, you can be 159.34. It's a continuous thing. So in order to split it up into clumps for a table like this, you want to make groups. So we use these little symbols here to show how it's split up. So this one here means that 150 is less than or equal to h, the height. So that means that anyone who's 150 centimetres tall would be in this group. And anyone who's 151, 152, 153, all the way up to, but not including 160. There's no little equal part on that. So anyone who's actually 160 centimetres tall exactly has to go into the next row, because there you can see the height. 160 is less than or equal to the height. The height is greater than or equal to 160. So 160 centimetre tall person will go in that row. So you get group frequency tables, and you can fill them in 5, 9, 6. So in this particular group of people, there were 5 people who were between 150, including 150 itself, and 160 centimetres. There were 9 people who were between 160, including 160 itself, and 170 centimetres. And 6 people in this range. And if you're 180 centimetres exactly, you have nowhere to go in that table. So if you have one person who is 180 centimetres tall, you would have to make another table for them. Another row for them. There they are. There is that person. And again, you can do a cumulative frequency. Column. And again, it's really easy. 5. 5 and 9 is 14. 14 and 6 is 20. 20 and 1 is 21. And next time we will talk about how you estimate median and quartiles from a grouped frequency table. So that's it. Cumulative frequency to column. Really easy, and you can use it usefully to help you finding median and quartiles if you prefer.